in honor of Electrical Safety Month, we try to bring some training every year. In the past, we've done some very, more specific arc flash and shock hazard training. This year, we decided to do more of an approach for managers and equipment owners so that you guys have maybe a greater understanding of your responsibilities and what the company and the equipment owner needs to do on their end as far as arc flash and shock hazard awareness is, both for your safety program and for your employees. So that's what we're going to focus on this year, for this talk. So that you guys know where you stand and where you might have some deficiencies or where you're right up to snuff, and so that your safety program is a very useful and safe tool for your employees. I have a little agenda with some categories, so you can see what we're going to cover. The very first thing, which is usually not the exciting part, is the regulations portion of why we do what we do. So arc flash and shock hazard safety in the workplace, which is what NFPA 70E is very clearly specified by governing bodies in our country. And it's not just you should do this because I told you so. It is regulated by OSHA. OSHA tasked the NFPA to come up with not only safety regulations, but maintenance guidelines and the National Electric Code. So the National Electric Code is an NFPA document. So all of those things go hand in hand. All of the NFPA 70 items and the NEC all work together. Along with OSHA, there might be state OSHA organizations and the Department of Mine Safety and Health all work together on safety programs and how to keep employees safe. The background on how we got to where we got for labeling and shock information and all of that is science-based. So the IEEE was tasked to do all of the calculations on figuring out how close you can be, what dangers are. So it wasn't a random collection of information. It's all science-based to determine where we're at and what we're doing. Obviously, common sense is also part of that. Sometimes that isn't always super obvious. And every 3 years when they redo the NFPA, it has to take into account the things that have not been covered by common sense, and we have new rules. So that's the basis for the regulations. There's a couple definitions that are super important as we talk about this. So anytime you see the word should, that's a recommendation. Anytime you see the word shall, that is a mandatory thing. Enforceable, OSHA directly refers to NFPA 70E and 70B in their documentation. And so a shall is definitely a trigger word for what you need to be paying attention to and how you need to be following along. Way back, I'll give you a little history. Way back in 1970, the number of people that were getting injured in the workplace got to a point where there was a movement that said, we need to try to make people safer at work. So it's been 53 years since the advent of workplace safety rules written by the federal government. Ralph Nader contributed to a lot of it in his early career. There's a very long history of safety, but that's how long we've had formal rules. Mines have had rules since 1977. Just in case anyone is from the mining industry, I have a couple little things for you in here. Before 1977, there were state administered plans, and the federal government said we need to standardize some of this, and we're gonna do some rules for mines. As I mentioned, state rules. There are some states that have their own state OSHA rules. None of these rules by these individual states can be less than the federal rule. All of these states have rules that are more strict than what the federal OSHA rules are. I know in Michigan we have very specific barricade rules that a lot of other states don't have. So that's just one example. Some of the states, per my little notes, only cover, the state OSHA organizations only cover public sector employees. Other states cover all employees. So it's important to pay attention to your state rules on how that impacts NFPA 70E above and beyond the regular federal rules. Just as a little background, the National Electric Code is the plain NFPA 70. So that is the guide for installation and safe and consistent electrical practices. The National Electric Code was not created to be efficient or convenient. It was done on a practical safeguard of employees. The important thing to know about the National Electric Code is the version of the National Electric Code as it applies to installations is decided on by your local jurisdiction having authority. So one city might be using the most recent National Electric Code. You might have the next town over or the next county over using 2014. You might have someone that's using 2000. So that installation code is based on your local area, and that's an important thing to note. The bigger thing, though, is when you get to electrical safety in the workplace, that is based off the most current version. Okay, so the local jurisdiction does not supersede federal safety rules. So they can't say, oh, well, we're only enforcing the NFPA 70E from 1997 and we're not doing 2021. That you need to keep in mind is the most current rule. 70E is electrical safety in the workplace. So all of that is based on any employee that's doing work that would expose them to electricity is your NFPA 70E. There's a picture of the handbook. The handbook is the one I prefer. Here's a copy of what the handbook looks like. As you can see, it's a large book. It's almost 400 pages. I have all of my tabs for the pages that I reference all the time because I get calls all the time about it. We're trying to condense this into sort of a chunk for you to take away on how you can streamline and get your safety program up to where it needs to be.
Denise said NFPA 70, that's every 3 years it's updated,
every 3
right?
years. Yep, every 3 years. So the new one comes out for 2024. This is the
Right.
2021. The new one comes out in 2024. I have not seen a full draft of it yet to see how major the changes are. I've heard that they're not extreme this time. The last 2 versions had some pretty big changes, and I think this one is lesser. I think there's a lot of consolidation of terminology and standardization of stuff through it and not as many changes. Just as a side, the National Electric Safety Code is the code that applies to utilities. So just thought I'd mention it in case someone ever, you have a question about that. And then the last part of it, obviously, we all know electricity can be dangerous and we need to use common sense when we're exposing our employees to hazards. So this is the responsibility part, and this is where, as managers and equipment owners, it becomes very important. Once again, in 1970, when OSHA really firmed up their rules, they came up with a statement that said employees shall apply. Employees shall comply with occupational safety and health standards, and that employers shall assess a workplace to determine if any hazards exist. So since 1970, it has been the responsibility of employers to find out where are the danger places in my facility and let my employees know. Okay. An interesting thing that happened a few years ago In the 2012 NFPA 70E, the mining industry was excluded per that article in the NFPA. In 2015, the mining industry asked the NFPA to remove that exclusion from the standard, but there was not a big push to let the mining industry know that they were excluded, that exclusion was gone. So what they call it is a silent inclusion. So I think some of it was to avoid an uproar, and so they just had the exclusion taken out. But it's important for mining associated companies to realize that this has applied to them since 2015.
And that wasn't just like, mines per se. I mean, it was also like aggregate companies or anybody that was in the downstream process of that too.
Anything that falls under the MSHA falls under this as well. So now all of those companies are included in the NFPA 70E. There is no exclusion anymore for different rules for mines.
And they're coming up to speed still on that.
Yes, they are. And a lot of it's because it was kind of a silent inclusion. A notice didn't go out to everyone that fell under the MSHA to say, you're now a part of this, So there are definitely some catch up that a lot of companies are playing because of the way it was included. It's an employer's responsibility to document safe work practices. And it's an employer's responsibility to provide employees with training on those practices and procedures. But it is very much a two-way street. It is important, and it's a requirement that employees follow the safe work practices that you have put out. They can't decide, well, I'm not going to wear that PPE because I don't feel like it and I never wore it before. If it is your documented procedure and standard for whatever they're doing, employees must comply with those rules. Okay, it's not that you're just asking them to, it's a rule. They have a little shall there, it's all a requirement. They have specific inclusions for host employers. There's a misnomer with a lot of companies that if I hire someone else to come in and do a job, I don't have to worry about it. And I don't have to worry about the hazard. And my guys aren't doing it, someone else is doing it. And so that's on them. That is not the law, and that is not how it works. A host employer needs to inform contractors of any site hazard that they can come across. We're required to report safety violations of contract employees. And if you know of a hazard, you need to inform that contractor of that hazard. You have to document the meeting, that you had a meeting, you told the contractor what the hazards are. That is a requirement of a host employer. Okay, there are some companies that I run across that say, well, I don't have any arc flash labels on my equipment because I don't do any switching. That doesn't fly because a host shall inform a contractor of what the hazard is. So that onus is on the owner of the equipment, the host company, so that everyone knows what hazards are present. Contractors, when they're at your facility, they need to make sure that all of their employees know these hazards after having a meeting with the host. They have to report any safety violations to the host, and they have to follow all of your safe work practices. So if you have a work practice that is more strict than NFPA 70E or more strict than OSHA, those employees must follow your work practices. Okay, it does not absolve the host from enforcing those practices. It's not an allowance to utilize practices that are less stringent than your own safety practices. Okay, so it's really important to know that everyone has to be working to the same safety level. The contractor needs to advise the host if there's anything, a hazard presented by something the contractor is doing. If you find a hazard, it has to be identified. One thing that happened to me, we were doing a shutdown at a facility, and when they shut the substation off, the basement that we were working in started to flood because they didn't realize that they shut off their sump pump equipment. Obviously, we had to inform the host of that particular situation. They didn't realize that that was fed off of that particular substation, and it created quite an issue. So, the communication between contractors and hosts are very important, so that everyone stays safe. And then if there's any violations, the contractor has to inform the host of how they're correcting those violations. So it's all very, very spelled out. The other issue on this second item, like a hazard identified, if you have a contractor, say they have to replace a transformer at your facility, they need to give you the information for that transformer so that you can take a look at it and recalculate any associated arc flash labels, because your hazard might change based on the new equipment versus the old equipment. So it's important that they communicate all of that information to you, provide that information to you, so then you can act appropriately. Okay, this is a long, very, very wordy slide. But these are all of the points that employers must have as part of your overall safety program, electrical safety program. So there's lots of components to an electrical safety program. I know this slide deck is going to be available, or the presentation is going to be available where you can freeze this. This is all part of NFPA 70E 110.5. It's very clearly spelled out everything that has to be part of your electrical safety program, and what you have to do. You're required to inspect your equipment. You're required to take into account the condition and maintenance of your equipment. You're required to teach your employees to have awareness and self-discipline. The E and F are program controls that are sort of nuts and bolts for your program. And then your program must identify procedures used before work begins, and you must have a risk assessment procedure. Now, as part of this whole thing, this requires documentation. So your electrical safety program must be documented. Your forms that you're using to do your risk assessment procedures need to be documented and maintained. Usually after, a lot of times people will call a job hazard analysis, a job safety analysis, a RAP, a risk assessment procedure. Everybody has a different name for it, but part of your program is to have these things documented, and document when work is going to take place that involves electrical hazards, and then that paperwork turned back in at the end of the job, so you have a record of that documentation. Okay, that's really important. The onus on electrical safety programs is a lot of documentation for the equipment owners. And the reason that is that shows process and intent. Okay, God forbid, should something happen, your responsibility and your participation in your electrical safety program then is documented to say, hey, we're providing training, we're going through all of these procedures. The people doing work are doing a risk assessment before they start the work, and we're trying to be as safe as possible. Okay. This risk assessment procedure must occur before work begins, and anytime there is an electrical hazard. Okay, so the handbook has a really good flow chart in it for how you create a form. There's also sample forms in there if you don't have one, so that you cover all of the bases on this particular work. Okay, this is the nuts and bolts and the important part of the documentation for a company. Okay, so the risk assessment procedure that we talked about. So before electrical work where an electrical hazard exists happens, you have to do these 4 things. So the hazards must be identified, the risks must be assessed, You have to figure out what risk controls you're going to use. And then you have to figure out, are there any potentials for shortcuts and human errors? And how are we going to get around those? You know, this usually goes hand in hand with your lockout tagout procedure, so that all of the risks are identified and covered. You know, talking about the work that's being done before it starts is a good way to catch when there's problems and when you're going to run into a hazard. You know, an experienced, qualified person is going to know. With like the plant that I was at, there was no experienced person to know, oh, when we shut this substation off, the basement's going to flood. You know, so talking about these things in advance, having your planning meetings and identifying all the hazards in advance prevent injuries and accidents. And that's a very documented OSHA documented statistic. You know, as we've implemented rules and implemented procedures, the number of workplace injuries has steadily gone down. So I'm sure you've all seen this before. This is called the hierarchy of controls. You can apply it to just about any hazard or any activity that you're doing. I even saw this used during the pandemic for PPE for the pandemic. It's important to know that elimination in the electrical world is ideal. We need to shut off the equipment in the safest way possible so that we can do work that is in an electrically safe work condition and the hazard is reduced. Some of these items are engineering controls and decisions that are made when new equipment's being put in. You know, substitution of equipment, that's not something you're going to do every day. But when you're making decisions on upgrading your equipment, you know, doing life extension programs, all of that, that's when substitution is there. The administrative controls are the rules that we put into place to keep our employees safe, saying you have to use this equipment. Here's the PPE. This is your procedure. This is how you have to do this. The very last choice always is your PPE. Selection of PPE and use of PPE is not a substitution for all of the steps prior to that. And it's important that the mindset of everyone at the facility is that way. Okay, we want to make sure that that's the last line of defense. Now, it doesn't mean that PPE is not used. Definitely does not mean it's not used, but that should be always the last step. This is 110.5I. This is part of that risk assessment procedure, and this is the job safety plan. So before a job starts where electrical hazards are present, whoever is in charge needs to create a plan, and they have to have the briefing. So that goes right hand in hand with that risk assessment procedure, because that's how you create your safety plan. So this is the actual documentation for your JHA, JSA, paperwork for your tailboard, whatever you call that process. This is the standard that references that. These are the items that has to be part of your job safety plan. It's important that the job safety plan be completed by someone who's qualified, that understands what the work is and what's going on. To be documented, just like I said, this is the paperwork part. So when you do the job safety plan, someone has to turn that paperwork back in, and it needs to be put in a binder on a shelf somewhere and kept. And then the hazards, the job, the tasks, the hazards, and the risks all have to be documented in that plan. Okay, so how are we going to do the work? How are we going to control the energy? What is the arc flash risk? What is the shock risk? All of those things have to be documented in that safety plan. This is the rule about job briefing. So this is your tailboard, tailgate, whatever you call your meeting. It's required that this be done in advance of the work. So everybody's got to get together. You got to talk about what everybody's doing, so that everyone knows what the procedures are, who's responsible for what, how are you controlling the energy, what PPE everyone has to wear, who's doing what. It is important that your job briefing process and your safety process be audited every year. So you need to go through your electrical safety program and this job briefing to make sure that it is up to par, that you're doing what you're doing, and that your process is audited. The other thing is your employees need to be audited every year. So someone has to go and look and see, okay, you did a job briefing, we did a tailboard. Are you doing it right? Someone has to show up and say, okay, they're really doing this. Everybody's there. Everybody signed the form. We have a plan. We have a process. We know what's going on. And that has to be audited. Employees have to be audited every year as well.
Hey, Denise,
Okay.
you said that the responsibility for this earlier in the presentation, you mentioned the equipment owner. Is it the equipment owner who has the onus of responsibility to ensure that this job briefing is occurring ultimately?
Ultimately, yes. I mean, normally it gets passed down to a manager. You know, there is someone that's the facilities manager or the maintenance manager or who's ever assigning tasks to be done. That's the person that's managing that. You know, if they're the one giving the job assignments, they need to make sure that the people that they're giving the job assignments to understand the jobs and follow the proper safety, procedures, and that person can check on them to make sure that they're really doing what they're doing. The company I worked for before, Anita Field Service Company, we had audits twice a year, not once a year. So somebody, you'd be on a field service job and the national safety manager would just show up and make sure that the paperwork was right, that everybody, everything was being followed the proper way, everyone was wearing the proper PPE, all those things were happening. So this is part of the verification that what you're telling your employees to do is being done and that there's a procedure. We don't want people winging it, because that's how things go off the tracks and people get hurt. So the more we can ensure that we know what's going to happen when we make a plan, the more successful projects and work is. So people go home at the end of the day the same way they come to work. Okay.
And remember, if anyone has any questions, please use that Q&A and I'll read those questions as they come in. Thanks.
And I do realize these slides are very word heavy, but it's you can't really consolidate when these are the rules. So that's why I like to talk about them, not just read them. But anyway, so that being said, your safety program has to have verbiage in it that says you're going to get your equipment to an electrically safe work condition. Okay, that has to be part of your program. You have to have a lockout tagout program, and your program, your field work, and your lockout tagout, like I said, have to be audited. So those things are supposed to be audited yearly, just to make sure that everybody's doing what they say they're doing, and you're really locking out things and working properly. Okay. Training. So this is where it's a little interesting with NFPA 70E. So employees are required to be trained in hazards, what hazards there are, how to recognize those hazards, what your safe work practices are, how to use their PPE and CPR and first aid. However, the training is not explicitly spelled out. So as long as the training meets these requirements, that is what they're looking for. There is no, you have to use this company. There's no requirement for how many hours the training is, because NFPA 70E's stance is that training is an ongoing thing that happens all the time. You're refining your safety program, you do a lessons learned after a project, and you might change your electrical safety program based on something that happened during a process or a job that you were doing. But these are the two other documents that reference that same training that NFPA 70E references, same exact thing. OSHA and MSHA reference the same training in their documents as well. Not just regular electrical work, but using electrical tools and regular tools that are in good repair, using good judgment, appropriate PPE. Those are all standard things in all branches of the requirements for training. This is the OSHA reference to instructing employees in the recognition and avoidance of unsafe conditions. Training includes electrical hazard awareness training. This might include lots of other training. You might have chemical training, chemical release training for your facility. You might have radioactive training that you have to do. Every facility is different, but this specifically references electrical training along with everything else. When I said they are very flexible on training, so it says you can have classroom training for your employees. You can do on-the-job training. It can be a combination of the two. How much training you give an employee is based on what they do for their job and what hazards they're exposed to. The big thing on electrical safety training is it must be done every 3 years. It must be documented. The NFPA rules for training indicate that there must be a sign-in sheet, there must be training, and there must be an assessment at the end of that training. And you need to keep those records so that you can show that you're doing this every 3 years. The reason the training is every 3 years is because that's when the new standard comes out. So at some point during that version of the NFPA 70E, you need to train your employees on the rules associated with that training, and it encompasses the changes in the rules. There was a very significant change to the lockout tagout procedure in 2018 that people still aren't sort of caught up with. And so that's the reason for ongoing training.
Denise, on that note about training and equipment training, and this is something I've been trying to drive home. We have a lot of, I'm sure, customers on the call here with ArcSafe, but would you consider the equipment training that we have for remote switching and racking to fall into that electrical safety work practices training that should occur every 3 years?
Yes and no. It partially covers it, but you're only doing the avoidance of arc flash, and there's not that component of shock hazard and where, what exactly is your shock hazard associated with then the arc flash. It is definitely a hand-in-hand training that goes with it, and that does count for some of it. But that's going to be a plant by plant, staff by staff decision. If you did 16 hours of arc flash and shock hazard training, then the next cycle, remote racking, on how to use equipment to stay out of the arc flash hazard, the customer would have to decide if that's adequate or if they combine that with then additional refreshers. Sure. It's kind of it's a lot of it is based too on the skill set of your employees and what on the job training you're doing as a regular part of their job. So if you can document that you're doing regular on the job training and you're making sure that people are learning and retaining information, that can certainly be part of it.
Yeah, I do have one question that came in. Is
Sure.
The training for outsourced work to let's say a third-party contractor or a facilities management company that maybe has an enterprise level responsibility, is that responsibility the equipment owner or that of that third-party provider?
It is the responsibility of whoever the employer of the people doing the work. Okay, for the electrical safety training. So if you're an equipment owner and you have documented all of the hazards, so you have arc flash labels, you've done your maintenance, you have maintenance records available for the people coming in to do work, and you are presenting them with all the hazards, the people that are involved with the electrical hazard, so the people that are in line of fire basically are the ones that need to be trained, and their company needs to provide that documentation to you that they are trained. Okay, so if you're hiring an outside contractor, it is well within your rights to say, hey, I want to make sure that everyone that you're bringing to my facility understands what this hazard is. I'm telling you what the hazards are, but you need to tell me that your employees are trained and that they understand those hazards. Okay, and that whoever is writing the job safety plan and all of that everybody down the line is trained. That's basically, so, if I'm a JLL and my employees are the ones doing the work, then I would make sure my employees are trained. If I'm hiring someone as JLL and they have an outside company coming in, I need to make sure with that outside company that their employees are trained.
Sure, thank you.
And because everyone is supposed to have this documented, that should be easy records for them to produce. So you want to make sure if someone's in and working on your equipment that they know what they're doing. Like I said before, God forbid something would happen, everyone is then involved. It's not just the contractor that's involved, the owner of the equipment is now involved, and you want to make sure that all the steps down the line that everyone is doing what they're supposed to be doing. Okay.
All right, thank you.
This little thing, so annually you're supposed to go over with your employees methods of release from electrical contact. So that's a little, monthly safety meeting, one month a year, that you do your methods of release. That's normally covered in the 3-year training for arc flash and shock hazard avoidance. But every year you need to go over that with your employees. What is our procedure that we're gonna have in place before we do the electrical work, that if someone gets shocked, how do we get that person out of that electrocution situation? And that's something that needs to be gone over with your employees every year. The first aid, CPR, and use of AED, they went back to the 2-year rule. For a hot fat minute, they required this training to be done every year. They have gone back to whatever the governing body is that does your first aid and CPR training, whatever the card is that you get, that is the time frame that training is good for. Most of them are 2 years. So you have the Red Cross come in and do your first aid CPR training, and they get a 2-year card. That's how often they need to be retrained on first aid, CPR, and AED use. Okay, so that's what that means. Satisfies the requirements of the body. So also keep in mind that employees responsible for responding to medical emergencies might not be first responders or medical professionals, depending on your facility. It might be a safety watch, it might be a craft person, it might be somebody else. So making sure that anyone that would be a first responder has this training is important. Some companies have like fire brigade people, and they're from different crafts that are part of that group. They're not dedicated to fire protection. It's important that anyone responding to a medical emergency have that training. So it might involve not just electricians, or electrical people. So that's important. The MSA has a requirement for annual safety training. So if you're a mine or fall under the MSHA rules, they have an annual requirement for training, probably because of the hazards associated with their facilities. I was going to say I saw a hand, but I think it's good.
You did see a chat, Denise.
Okay.
Maybe, and one of the questions, what is a viable resource for methods of release training?
Okay, so the handbook has what that is. You can look in the handbook and decide if someone in your company is qualified to provide that training. It's not anything super complex. Are we using a safety hook? what equipment are we going to have in our facility, to release someone? Are we going to go through all of the ways that you can remove someone from being shocked? Make sure that there's a 2x4, that you could knock some out of the way, use a trash can. It's not, they don't have anything specifically spelled out on that. So I advise you to look at the handbook, see what the handbook specifies, and that's usually something you can handle in-house. That's going to go hand in hand with your electrical safety program. If you're buying rescue hooks and you're going to be doing something where switching, or you have to take readings and someone is going to be exposed to live 480 or live medium voltage equipment, okay, where's the safety hook going to be? Who's going to be manning the safety hook? And doing all of that as part of your safety process. So that's
thank you.
Did that answer your question?
I do believe it did. Okay.
All right. Yes. And Tim said it must include how to isolate power to the sources. That's one of the things, so can you shut the power off? That's one of a method of release. If there's no way to shut the power off where you're working at, then you have to have a whole other list of what happens in the worst case scenario. We can't shut this off. The disconnect for this is a quarter of a mile away in the plant. So there's lots of components to not just shutting off the power, but looking at, what the individual task is and how are we going to mitigate this. So your training needs to be verified and documented annually. So what that means is you need to go through your records and you need to say, okay, all of these people are current on their NFPA 70E training. All of these people are current on their CPR first aid and AED. Oh, look, we have 5 people that need CPR first aid and AED. The going through your records and documenting where everyone is in their cycles is a requirement of your electrical safety program. As long as an employee works for you, you have to maintain those training records. Okay. Once the person no longer works for you, you don't have to keep those training records, but it's an ongoing process to make sure that there's consistency in training as part of your program. Okay. So, a spreadsheet, something that you can print out every year to put in a binder that says, hey, we went over, these are all the employees, these are the trainings, this is where they're at. However, your particular company decides to keep track of that, that's everybody does it different. I think there's software that keeps track of it, just like there's software for equipment maintenance. There's all different ways to satisfy this requirement, but it has to be documented. And the documentation usually comes up when there's an incident. When OSHA shows up at your building because someone got hurt, then that's the first thing they're going to ask is, where's your documentation, for your electrical safety program, that you go over the program, that you have the records of training. We know there was assessments done. You're doing everything on your part to try to keep your employees safe. So little definition, a qualified person. So I mentioned previously that qualified people must do your job safety planning so that they can recognize hazards. It's important to understand what people you have targeted as your qualified people, and know that oftentimes it might need to be more than one person. Part of the reason is you might have somebody that's qualified and is knowledgeable about many of the pieces of equipment in your plant, but not all of them. So just because someone has been a licensed journeyman for 30 years doesn't mean they're qualified on every single piece of equipment or job task that is involved in your facility. So targeting those people and making sure that you have qualified people doing your job planning and your safety paperwork and all that is really important. Qualified people need to determine what extent of PPE needs to be used, and they need to be familiar with the selection, operation, and limitations of the test equipment that they're using to guarantee people's safety. Okay, so that's a good training equipment training and a voltage detection equipment training is a good training to do, you know, in an off year when you're not doing your NFPA 70E. You know, the following year you can do your voltage detection equipment, procedures for using that equipment, making sure that all your equipment is up to par, you know, that you're using to base people's health and safety on. Okay. The qualified person must be able to make decisions about the job safety plan, about identifying the hazards, and select the appropriate risk controls. The qualified person should also be able to identify job tasks that should not be done. You know, they should be able to assess the situation and say, okay, the hazard on here is above what our company allows us to do. Now we have to do this a different way. And they need to be qualified to be able to make those decisions and bring that to management or supervision to say, hey, this shutdown, we need to do this a little bit different way because of the hazards involved. Okay. And you know your employees, you know, you work with them, you know what their skills are, you know who to make sure has enough information to be the qualified person. I want to talk a little bit about test equipment and test instruments. So this has its own section in NFPA 70E. Only qualified persons can work on energized equipment. And only qualified persons can test and troubleshoot equipment where an electrical hazard exists. Okay, you want to make sure that anyone that's putting themselves into an electrical shock hazard or arc flash hazard is qualified and understands what they're doing, the equipment that they're using, how they're using it to avoid issues. This test instruments and equipment shall be rated for circuits and equipment that they are utilized. The reason it's important to have a qualified person doing this is you want to make sure that you don't have someone that takes a fluke and puts it on a medium voltage piece of bus to see if it's dead, because that fluke is not rated for that medium voltage equipment. You want to make sure that everyone that's involved in those steps is using the right thing. Are they looking at the category rating of the equipment? Is that part of your job safety plan, that the correct equipment is specified so that mistakes like that don't happen? A big thing that I don't see it too often, but every once in a while I still run into it. The steel industry is big for people using wiggies. It's a little square thing with two little leads. One of them comes out. Those are illegal. You cannot use wiggies anymore. It's important that your test equipment and the devices that are being used in your plant are recognized, rated, and that people don't have that in their bag because, oh, I've used that for my whole career and I love my wiggy and I'm going to continue using it. You know, it's important for equipment owners, managers, people that are decision makers to make sure that when you do that field inspection, you make sure that they're using the right equipment. Okay, even if you've provided with them with the right stuff, they might not actually be using it. So that's a really important thing. Always inspect equipment before use. It's a rule. The NFPA specifies that anything over 50 volts be tested using the live dead live method. So you use your test equipment. You make sure your test equipment is working on a known source. You check the thing that's supposed to be dead, and then you check it again on the live known source to make sure your test equipment is working. I know myself, I do not want to trust my life to a piece of equipment that I'm not sure is still working after I tried it. So that's the reason for the live dead live method, and that is specified in NFPA 70E. Okay. The NFPA 70E has a whole chapter on establishing an electrically safe work condition and what that means. Section 120, chapter 120 has all the lockout tagout rules. That whole section is how do you get to an electrical safe work condition. Okay, and it does have a couple of the exemptions of what's considered energized work and what isn't. So it spells that all out in 120. Like I talked about, they changed the NFPA, changed the lockout tagout rules. There's two different kinds of lockout tagouts now. There's a simple and there's a complex. There's 8 conditions for the complex lockout tagout. They are not very, the bar is not very high. If you have more than one energy source, more than one crew, more than one craft, more than one location, more than one employer, if it extends to more than one shift, if there's a specific procedure that needs to be followed to shut the power off and turn it back on again, all those things now make your lockout tagout a complex, and you need a separate form. And so that all goes with the documentation. If you're locking out one disconnect, 2 guys are working together, they're working in the same place, they can see each other, it's not different locations, one power source, all good. That's still a simple lockout tagout. But if you've got a guy from the motor company and one of your electricians and you're locking out one source, you still have 2 crafts, 2 employers, and now it's a complex lockout tagout. The reason they did the complex lockout tagout was because they realized that people were getting injured when one craft or crew didn't realize that someone else was working in an area remote to them that was involved with the electrical work. So they would turn the power back on and someone would get shocked. So they came up with this based on what the injuries were and what they continue to see with injuries. And that's generally the case with all of the specific roles that are put in the NFPA. And that's another reason for the every 3 years is they analyze all of the injuries and all of the deaths from the previous cycle to say, how are people still getting hurt? What do we have to do and how do we refine this? So that's section 120.
Yeah, Denise said, I just got a note here, said the lockout tagout image shows the padlock in the wrong hole.
Oh, probably. Yeah, yeah, sorry, I pulled that up, a warning label that I pulled. So it is, it's in the wrong hole. Apparently I have to get a different image from that sticker, but thank you for letting me know.
Yeah.
I think people do that in their tool bags, you know, that's probably why, but thank you for letting me know. The NFPA says you have to have shock hazard training, okay? So your employees need to know what the limited and restricted approach boundaries are, how to recognize that, how to select the proper PPE, same thing, correct gloves, correct suits, whatever they're wearing. That's part of the training, the required training. Arc flash training is required every 3 years. So people need to understand what is an arc flash. How do you assess your danger and the risk? What are the boundaries? How do you pick your equipment and how do you read a label? Okay, so all of that is part of the arc flash training. It's required that you give preventive measure training. So once again, we're, you know, the hierarchy of controls. So how do you teach your employees to avoid hazards? You know, you're teaching them how to recognize the hazard. Now you have to give them the tools to avoid the hazard. This is the ANSI. It's also in the ANSI Z10. So same thing. All of the standards go hand in hand, and it's the same messaging in every standard. Okay. The preventive measures training, like I said, lockout, tagout, grounding training, training on equipment that you have. How do you use engineering controls to reduce exposure? You know, what does the distance on the label mean? How to read a label and how to select your PPE. Okay, this is the NFPA 70E's definition of an electrically safe work condition. So the circuit has been disconnected, locked and tagged, tested, and grounded if necessary. That is an electrically safe work condition. Oftentimes you have to do troubleshooting with the power on. That is not, troubleshooting by a qualified person is not considered energized work. However, that once the determination of the problem has been found, it is required that you get the equipment into an electrically safe work condition to repair it. You know, you can't figure out why a press isn't working sometimes if you shut it off. You have to do a little bit of, you know, meter work, a little bit of troubleshooting, and then you shut it off to fix it. Okay, this second item, the troubleshooting while energized, you have to be careful that that's not being abused. You know, you can't just say, oh, I was still troubleshooting. That doesn't fly. You know, you have to make sure that you get equipment to an electrically safe work condition, and that's part of your job plan. The NFPA says equipment must be maintained. So the equipment owner is responsible for documentation that their equipment has been maintained, usually per the OEM's recommendation. The NETA MTS has some guidelines on maintenance requirements if the OEM information isn't available. They have some more generic guidelines on maintenance and record maintenance and equipment maintenance, and then the availability of the records. That's really important for your employees doing the assessment for their job hazard analysis, you know, their job safety planning. They need to know, has this equipment not been looked at for 15 years? That's going to change the dynamic of how they approach the job and the precautions that they have to take versus work that was done every year on the equipment, and you have a very good history of that equipment. Now, that being said, the NFPA has a document called 70B, which is standard for electrical equipment maintenance. The new version of 70B, the 2023, has now specified that maintenance is a shall, not a should. Okay, so there is no document that says, well, we didn't maintain it because we didn't feel like it. Everything now is aligned to you are responsible for doing maintenance on your equipment to keep it in safe working order. Okay. There's a table in NFPA 70B that is pretty good for timeframes, what the recommendation is outside of the OEM's recommendation. I also have this on the overcurrent protective device. So if you don't maintain your equipment and you don't test your equipment, those devices that are going to trip your breakers might not work the way they're intended. And so your hazard to your employees greatly increases when equipment does not operate like it's supposed to. So if you have if you have a breaker that is supposed to trip in, for example, 0.143 seconds at 8,000 amps, the calorie label on the door says that it's 2.4 calories, and this is the PPE that you need to wear, and this is the hazard distance and all of that. If that same device doesn't operate for 2 seconds, now you're at 30 calories. And if something happens while that equipment is being operated and it doesn't operate as intended and there is an arc flash event, your employee standing in front of it only wearing 4-calorie protective equipment is grossly underdressed for a 30-calorie event. So it's important to know that is the reason why your equipment must be tested and maintained, because the hazard drastically changes for your employees. Okay. That inclusion in the 2023 70B is a big deal. There's been lots of rumblings since that came out. And a lot of this is driven also by your insurance companies. You know, your insurance company, you know, can come back and say, well, we're not going to insure your plant unless you can provide documentation that you're actually maintaining your equipment.
Hey, Denise, I do want to mention, you know, we're right about an hour now, which we had planned. Okay. However, you know, I think we're coming near the close end of it. I do want to mention that, yes, there'll be a copy of this presentation available. We can send slides out, right?
Yep.
And then
let me zip through. I can zip through the thing like we talked about. Labels are required. Let's get this close in case everybody has a question. This is a standard label. These are the requirements that what is on the label. Thank you for letting me know. When do I have to wear PPE? Whenever there's a hazard, not just electrical hazard. There's an Article 137 says we have to wear PPE. I'm sure you got, how many minutes do I have? Not very many.
Well, I think it's okay if you want to keep going. I just want to let everybody know that we'll have these available, and that we'll still have time for Q&A after this, and
yeah, I'll stay.
Not to rush off necessarily, but I just wanted to let everybody know that this will be available because that's one of the questions that came in, and I have a couple more as well.
Okay. So this is the chart that the NFPA has for PPE. Justin and I had a conversation about what happens over 40. We can talk about that at the end because that's an interesting dynamic of things. I'm not going to read these. This is available everywhere for your review on what is required for each hazard level based on your labeling in your plant. Equipment must be tested, gloves must be tested every 6 months. They changed the rule on that. It used to be you could use them in a 6-month period during the year that they were valid. That is no longer the case. The gloves are only good for 6 months from the date of testing unless they're brand new, and keeping track of which ones are brand new and which ones are back from the lab is almost impossible. So basically your gloves can only be used for 6 months from the date of test on the glove. That was a big change in the last version. And then conclusions, make sure that, we need to make sure that we have a safety culture at all levels of our facilities. And we need to make sure that our employees are using their PPE. The worst thing to see is a picture where someone's in the hospital and the arc flash suit is zipped up in the bag in the corner. So we want to make sure that our employees are doing what they need to do. Have I had a 40-calorie suit on in 110 degrees in the sun? Yes. Does it suck? Yes, but it's required. This is the STAR protocol. Not everyone's heard of this, but this is a really good way to approach safety with your employees. The Stop, Think, Act review, really catches a lot of potential hazards if you use this protocol and peer review. And then in summary, make sure you implement your safety program, make sure everyone is trained, evaluate your employees to make sure that they're qualified, make sure you have a written job hazard program and that your equipment is labeled. And then this is contact information for Justin and myself. As part of the engineering controls, if you have any questions on CBS ArcSafe products, to get people out of that arc flash zone. We can't always prevent an arc flash from happening. You don't really know what's going on behind the door, but if you can get your employees to a safer place, do switching upstream, use a device, so that people aren't standing in front of it. That's a very good approach. So any questions? I'm sorry I went over.
That's okay. Hey, listen, I think earlier you mentioned NETA MTS, and we have a mixed bag of attendees, I think. Okay. Some managers, some, ESH folks, and maybe not electrical. Could you tell us a bit more about what NETA MTS means?
Right. So NETA is the National Electric Testing Association, international, but they use the N. And they have developed 2 standards. One is maintenance testing standard, which is MTS, and they have an ATS, which is acceptance testing standard. So there are different test parameters for new equipment, and that's what acceptance testing is. And then their MTS, which is their maintenance testing standard, is for existing equipment. So that NETA MTS goes hand in hand with the NFPA 70B on electrical testing of equipment and what you should be doing. The information, test values, all of that in the NETA MTS were developed also by IEEE. So all of those numbers, what, insulation resistance values are supposed to be, what contact resistance values are supposed to be, how cables are supposed to test, all of that is spelled out in the NETA MTS. So it's a very good guideline alongside the OEM information. Some OEMs provide a lot of information for their electrical equipment and others don't. If you have older equipment, not everything might be spelled out. So it's a nice set of documents that you can parallel to make sure that your equipment is being tested properly and that it's going to function the way you expect it to. So
Yes.
that's what the NETA MTS is.
Walter asked, do you need an energized electrical safe work permit for troubleshooting?
No, you do not. That is in the NFPA 70E. But definitely I would make sure that in your job safety plan that it is specified that after the troubleshooting is complete, that then you're going to get the equipment into an electrical safe work condition to do any work. You have to have that differential of activities. And then the other thing is you need to also consider what troubleshooting you're doing, at what voltage level you're doing that at, and what the hazard is. So you need to make sure that those, if you're troubleshooting a circuit on a press, that's a lot different than troubleshooting energized 15 kV bus. So looking at the task at hand will guide you into where you're at in the tasks that you're asking your employees to do. But no, it specifically says that troubleshooting is one of the exclusions and is not considered energized electrical work. I think installing monitoring equipment is also not considered energized electrical work, even though the hazard is very high. So that's also take that under advisement activity.
All right. And one thing that you kind of went quickly through toward the end there, and I think it's a really good thing to just review. If you could bring back up the slide on the STAR protocol, because sure. If you want to touch on that at just a high level, I think that's a good slide.
Yeah. So when you're preparing your job safety plans and all of that, that is part of this protocol. You're stopping to think about what is the task. What do I need to have for my employees? What are the procedures that they need to do? We're trying to figure out what's the safest way to do this. How do we come up with the safest plan to do work that involves shock and arc flash hazards? The big thing on the think part goes hand in hand with the qualified person. Do I understand the task? Do I know what my boss is asking me to do? And making sure that when you're working with your employees that they really understand what the task is and what's going on. Do they have the right tools? Do they know the procedures? Is everybody on the same page? I think it's important to recognize as managers and equipment owners that not everything in the safety world can be done super quickly, and recognizing that sometimes the act part takes a little bit. I realize that, costs are high. We pay employees a lot of money, but taking the time to do things in the right steps, take the extra 10 minutes to put your flash suit on, take that time to inspect your equipment before you starting. Doing all of that saves all kinds of grief, time, and aggravation later. So that's important to know. The review part is really important when we complete a task and maybe things didn't go exactly as planned. How do we get my customer to say, hey, next time you do that substation in the basement, let's make sure that we have that pump on generator so that the basement doesn't flood, those kind of things, so that in the future you're eliminating hazards. You don't have a hazard of someone slipping on a wet floor. You don't have a hazard of your substation getting wet. You don't have all of those hazards. So going through the review process after a task, especially a complex task, is really important so that we can make corrections and move forward. It's kind of like, using the near miss forms. A near miss form isn't designed to get people in trouble. It's designed to improve the process, and making sure that everyone understands that. Now on the think and act, that's definitely a nuance with your employees, and the, do I understand the procedure, that kind of thing. It's not, well, I'm not doing this job. It's getting to your employees to say, hey, I know you're asking me to do this tomorrow, and I want to make sure that I understand the procedure. Or asking the employee, hey, we're asking you to do this tomorrow. Do you know all the steps you have to do? We want to make sure that everyone's on the same page, that having information makes a safe employee. If you're hesitant because you don't really know what you're doing, that dramatically increases your risk of injury and things not happening the way we anticipate them happening. So making sure that you have the right people on the job, there's a lot of nuances to this, people's mental states and, did someone take NyQuil on their way to work, and, all of those things. But that all of those things go into that, and the awareness of supervisors and managers and planning out safety work.
One of the other questions,
yep.
Denise, is what do you consider monitoring equipment?
So if you're putting like I know AEMC makes one, like flexible CTs and voltage clips to have maybe a recorder, and say, hey, we think we're drawing, we're using more amps than we've anticipated, or can we add another circuit to this motor control center, or are we already at the max, but we really don't know if we're at the max because there's no metering, there's no anything. That's what they mean by monitoring equipment. So temporary equipment to check a circuit or monitor a situation.
Got it. Good. One thing that you touched on, and I think this is kind of a big conversation point, at least internally, is the 40 calorie mark. We mentioned that it'd be a longer discussion, but a lot of our customers use 40 calories as kind of the point at which they say, well, we're going to employ remote racking, remote switching. And there's some conversation, I think, in IEEE about whether 40 calories is the right mark to choose for that, or if it just has to do more with current. But you had some thoughts on that when we were talking earlier.
Right. So in 2015, the NFPA 70E had a note about any work done over 40 calories should require extra planning, decision-making, and care. When that note came out in the 2015 NFPA, it had kind of an opposite effect. It made people think that, well, nothing below 40 is really that big of a deal. So they removed that from the standard. The reason that a lot of engineering firms and companies use the 40 calorie mark as the cutoff is this chart right here. The NFPA does not specify what the equipment is to wear above 40 calories. So many engineering firms, when they calculate labels, because there is nothing specified by the federal government as safe to use, they say no PPE exists. And that's how they do the labels. There is PPE above 40 calories. It exists. You can buy it, but there is no guidance for, do you have all the right components? Is the item that they're using safe enough? And should you be putting an employee in that position when equipment starts to break apart above 15 calories? So is that 200 calorie suit, the Kevlar that the 200 calorie suit made out of, is that adequate to prevent an injury if something goes wrong while that person has that suit on? So that's why many companies and many engineering firms and labels and all of that, once it hits 40 calories, they just say, you know what, you need to find a safer way to do this. So that's how the advent of that happened. And until the NFPA specifies clothing above 40 calories, I do believe that's kind of the stance of a lot of people, that it's just not worth the safety risk to be switching at astronomical calorie values. Once again, if equipment is maintained, if it was installed properly, if all the doors are fastened, if you know that the trip unit works, if all of those components are exactly right, is there really a hazard? Maybe not, but we don't know. You don't know if a critter got in the back of there, and when you go to open that breaker, the breaker can't open, and then you end up with an arc flash event. You don't always know standing in front of it, and that's the reason why we suit up, just in case. So does that answer your question on over 40?
I think so. Yeah, I think so. Thank you for that. It's not uncommon that we go to a site and we find equipment not well maintained, and you realize that the stickers on there really don't have much value if something's sticky and not tripping on time, or if it's just not operating it as quickly as it should when you go to operate it. Yeah, I mean, that's,
you press the button and nothing happens.
Who knows what your values actually are? And we see a lot of dirty facilities out there, unfortunately. So sometimes finding that normal operating condition, it's common. But
I would definitely say that if you're asking employees to wear PPE above 40 calories and do switching, and operating, you should very much make sure you have a robust electrical safety program documenting all of why you think that's okay. That's definitely an onus on the equipment owner on those procedures, and figuring out, I bought a 200 calorie suit, but are the gloves adequate at 200 calories? And do I have to buy special gloves? And are the shoes adequate that my employees are wearing? Because a lot of companies don't buy employees boots. They're required to buy their own boots. Well, are leather boots adequate at 200 calories? Those kind of decisions have to be made by the company when you go into those higher levels.
Denise, I want to bring up one more thing, and I apologize. I know we're over, but this is good content, and you're such a great conversationalist on this. Could you go back to the slide where you had the arc flash labels?
This one or the other one? This one?
You have either one that you could talk about. And I only want to bring this up because sometimes I've been in facilities before where I've walked through and they had arc flash labels on the equipment, but sometimes management didn't really know what the labels were about, or even what kind of hazards they had. I've been in facilities where they had breakers over 100 calories, and I'd ask them, what is your procedure to switch this? And they just looked at me like, what do you mean? And I think that's not uncommon for them to have arc flash studies, but sometimes the operators and the people around it maybe don't even understand what the stickers are saying. Is that something worth touching on this call, since we may have folks here that are not electrical?
Sure. So this particular label, the arc flash protection is listed on the left. The shock protection is listed on the right. There is no rule in which order everything has to be. All of the labels just have to have these components on them. It has to list what the arc flash boundary is. It has to list either the calories, this one is 0.4 calories, or the hazard risk category for the clothing. So like the 0, 1, 2, 3, 4 that I showed you that chart, it's got to have one of those on there. If it has the calories, it's the responsibility, whoever's planning the job, to go look at that chart and say, okay, at this many calories, what do I have to wear? If it says the hazard risk category, then you just look at that 1, 2, 3, 4, 0, 1, 2, 3, 4, and you're right at that thing. Working distance, it's usually this one, because the calories are low. Working distance is 18 inches. That means the length of your, where your hands are doing a job. That's 18 inches from your hands to your face, is basically that. If you have a value that is exceeding that arc flash. So if you have a higher arc flash, that working that you see, this boundary is 0.9 feet. So it's not even a foot at that 18 inches. If as the calories go up, that arc flash boundary moves. Okay, so it gets further and further away. You might see a label that says 54 calories and 165 inches. Well, 165 inches is way further than you can reach to do your job. And that's the boundary with which you can get injured. Okay, and that's injured wearing your PPE. Okay, that's another misnomer. Just wearing PPE is not a guarantee of injury, non-injury. The use of PPE is supposed to guarantee recoverable injuries. So second-degree burns or less. So you keeping that in mind, that you won't necessarily not be hurt. It's just supposed to prevent permanent injuries. It's important to know on the shock protection side, you might see older labels that have 3 boundaries, prohibited, limited, and restricted. They got rid of the prohibited because they found that that was the only thing that people were paying attention to. That label can still be there. But what you want to pay attention to is limited and restricted. Those are the 2 that are on any recent label, is going to have limited, restricted. The prohibited for 600 volts was like 1 inch. So people were like, oh, well, as long as I'm an inch away, I'm fine. And that wasn't the intent. So they took that category out, and it's only limited and prohibited now. So, or limited and restricted now. So that's the thing. It's also important to know that at every voltage class, that shock protection distance is going to be the same. So every single 480 volt panel that you have in your plant is going to be 42 inches and a foot, but your arc flash side is going to change with every single piece of equipment. Okay, based on what the equipment is, what the load is, how big the cables are, what's feeding it, all of that. Same thing on the shock side. If you get to a medium voltage level, that medium voltage shock distance is going to be the same at that voltage class level, but your arc flash side is going to change. I've been in facilities, I saw a facility and I felt really bad. Every single label in the entire plant was identical. Well, I can tell you right now that that's worthless. If every single label at every single amperage level of every breaker is identical, someone didn't do their job. And you can't trust those labels. So the only other thing I'll mention about the label, you see this one was done in 2018. In 2018, the IEEE came up with some new formulas for calculations they take into account direction of the bus, whether it's enclosed, whether it's not enclosed, and depth of cabinet. And if you have a piece of equipment that the cabinet is very shallow, like a motor control center or a disconnect, and your incident energy is high, and that was calculated before 2018, that might be something you want to consider get recalculated, because that might put that over that 40 calorie threshold that a lot of people use, because there's a new constant in the formula that takes shallow cabinets into account, because they were noticing that the fault damage was different. And so they said, okay, there's not as much area for an arc flash to go when it's a shallow cabinet and the hazard is higher. So now that's a new part of the calculations as of 2018. So that's a thing to think about, as you look at your equipment and look at your labels, whether you want to consider recalculating those ones. Now, if you have something that's 0.4 calories and it's a motor control center bucket, it is not going to increase enough to be worried about the 40 calorie situation. So it's a equipment by equipment evaluation of your label.
One of the questions here, Denise, is does the warning label have a date? Which it does. It says when you have a low voltage equipment like a lighting panel board fed from, for example, a 112 kVA transformer or below, does the arc flash change significantly?
That's all dependent on your equipment. How close is the transformer to the panel? How big are the cables? What's the impedance? All of that is equipment by equipment based and can change dramatically. I would say take a look at that label and see how high your calories are. You know, if it's close to going from one category to the next, you know, if you're at here's the calories, you know, if you're at 7 calories and it's a shallow cabinet, or you're at, you know, 24 calories, you might want to get that recalculated, because it might pop you into the next category of PPE so that your employees are protected properly, you know, so they know, you know, that's I hate to say it and I hate to not give you an answer, but that's a case by case basis based on supply. You know, if that 112 kVA transformer is halfway across the plant and you have a lot of impedance from the cables, you know, it's not going to change it as much as if the transformer is sitting right next to the motor control center, you know, next to that panel. So,
well, I'll tell you what, we are right about an hour and a half, so we've gone over what we intended.
I'm sorry.
So don't be sorry. You're full of great content. What I would say is, if you have questions, please shoot us an email. Denise is available. You send them to me, I'll share it to Denise.
Yep,
if you need a certificate of attendance, again, email me. My email address is right there, jgall@cbsarcsafe.com. I'll get those out by the end of the day tomorrow, and then by next week we should have this video recorded and uploaded to our YouTube channel. Probably mid next week. We'll do some editing to it and have it there. We'll send that link out to the registration list. Let's see, the copy of the slide deck, we'll make that available as well. We'll send that out. That can come tomorrow. And if there's any other questions, again, email us or feel free to give us a call. Always available. We really, you know, I think these initiatives are great. I mean, if you look over the past 10, 20 years, arc flash incidents and energy, well, maybe not incidents, but injuries, as far as I could tell, have been on the steady decline. There's still shock hazards, and that's becoming a bigger part of the conversation again right now, which is good. But I think it's because industry is taking this seriously, and they're taking electrical safety seriously, and because of OSHA and the work of IEEE and all these organizations working in concert, we're seeing an effect here, and we don't take our eye off the ball. We stay on this, and it's a big deal. And I applaud you all for taking this initiative, taking your time, and making your electrical safety program a very important part of your company and your employees' well-being. So thank you for that. Denise, anything else to add?
No, I was just going to say I'm in sort of a unique position. I've been working in this field for 33 years, and I've seen the entire advent of PPE, from the very first arc flash suits that were invented to where we're at now. And it's been an amazing view on the protection equipment that are available, you know, that's available for employees, and how we really can utilize this equipment and procedures to keep people safe and stay safe. It definitely is very much different from when I started, you know, and what was even available to purchase, you know, to now. So, so once again, the resource, I prefer the handbook if you're going to purchase this from the NFPA. The new one comes out sometime after September, October. Yep, there it is. They are not offering it in a PDF because too many people were sharing it. And so they make you buy it, but it's a fantastic resource. There are forms in there. If you're lacking in the paperwork side, there's sample forms that you can copy. They don't care. You can use their thing. There's flow charts. There's, you know, everything for refining your electrical safety program. They really do a good job in the handbook of making sure that everyone's on the page. It's supposed to be a resource. This is supposed to be what we use so we don't get in trouble and that we keep people safe. So they've really done a lot of work and provided a lot of resources for all of us to use.
All right.
Thank you so much.
Thank you, Denise. Thank you all for joining us today.
On my long-windedness.
I can't think of a better way to go into Memorial Day weekend here, and hopefully we come back to work with safety in mind. So good job, and thank you very much. Y'all have a great day.
Thank you so much.
Bye.
Bye.